we've got our problem statement, and we also need to beef that up in terms of what exactly are we designing for. Okay, so having identified that gap, the problem that we are solving, we need to be really clear about that and be able to explain that very, very well. So we need to work on that in addition to building the prototype. So we build a case. We need to think about potentially, one of the things about it is to think about the market, but if you move a step back, the magnitude. So are we making something that will make 10 of them, 1,000 of them? What is the magnitude?
This is difficult. This is the first time you're doing this. It's something which you discovered. You began to understand from the user's point of view.
Whatever we are trying to address on this, instead of making it, because the problem that with the current ones is they are being turned, they are the screw ones, and they fail with time.
Because for now they don't have it, so what we're trying to make is something cheap and available, so that even can be used in the low resource settings.
The ones that are displayed are those two. You can see the doors, and above the doors there are display lights also to notify the nurse that this is the one where there is the need for help.
Patient monitors, it doesn't need a patient to press on a button to need an assistant. There's some vitals, signs, like patient monitors. If there is a urgent attention, if it goes below some point, it alerts a nurse in nursing station automatically.
This is quite ideal because it doesn't involve many things. It does not involve complex systems like turbines or anything. So just few lenses, mirrors would do your thing.
When you're developing your concept, your design, or your product, all these people have to be put into consideration, but you may not be able to fulfill all their requirements.
So if your problem statement has your solution already, that kind of limits you to what you can do.
We use the theory of sweating. So when you sweat, when the wind blows, the evaporating of that sweat is what makes you cool. So the same theory here.
So these parts are constrained, so because like they would be in real life. So like if you try to move these ones can't move, but this one is not fully constrained. You can see it can move that way and this.
So I don't get why do we need it? And then again, who is the user? We are adjusting it for who? Because I don't know whether nurses complain because of the IDP.
We try to minimize on thinking how will I manufacture this process. We need to be able to manufacture this in Kenya or any other country that you have to consider that.
So what we have is a simple proof of concept.
Something is locally available or can be recycled from something that is the preference as opposed to importing something.
In terms of observations, this is what stood out for us. Most equipments were missing parts, or the design of those parts were poorly designed. So we were like, that's a problem and we need to approach it.
So basically, that's our oxygen concentrator. In the design, we are yet to do the design models and the sketches. So yeah, that's it.
The mothers who were there when we visited, we noticed that for them the food was cold. The way that you, for example, it's placed on the plate or even on the warmer itself, it's not able to keep the food warm long enough.
And so we are looking to you as the young generation to come up with good ideas that can be easily replicatable. We are looking at the economics of things. We are looking at being efficient, being innovative. At the end of the day, we are saving mothers' lives.